You watch something happen, and you already know how it will end. A drop of ink falls into a glass of water. It spreads. Thin threads curl outward. The clear water turns cloudy. You don't expect the ink to pull itself back into a neat drop at the bottom of the glass. A door slams shut. The sound echoes and fades. You don't wait for the air to gather itself and push the sound back into the room. A match burns. Heat flows into the air. Light disappears. You don't expect the flame to rebuild itself and jump back onto the matchstick. These expectations feel natural. They feel built in. The world moves forward, not backward. But pause for a moment and look closer. Nothing in these examples is being pushed forward by some visible force called time. No signal announces that one moment is allowed and the other is forbidden. Things just unfold in one direction, and we accept it without question. Now think about what the basic rules of nature actually say. When scientists describe how matter moves and interacts, the rules are precise and strict, but they are also strangely neutral. They do not prefer before over after. They do not label one moment as special and another as off-limits. If you take a simple physical process and imagine it running backward, the rules still apply. Motions remain allowed. Interactions remain consistent. Nothing breaks. At the most fundamental level we know, nature does not insist that events unfold the way we experience them. And yet your experience is nothing like that. You carry memories of what has already happened. You do not carry memories of what has not. The past feels locked in place. The future feels open, uncertain, waiting to be shaped. You act as if choices point forward. You speak of causes leading to effects. You feel time passing, not hovering or reversing. This difference is so familiar that it feels meaningless to question it, but it is anything but meaningless, because the pieces that make up your body do not experience time this way. They do not remember. They do not anticipate. They follow rules that make no distinction between yesterday and tomorrow. So where does this strong sense of direction come from? To see it, imagine something ordinary. Take a sealed container and fill it with air. At first, imagine that the air is uneven, denser in one corner, thinner in another. Then leave it alone. Over time, the air spreads out. The dense region fades. Everything evens out. This always happens. Now, ask a careful question. Could the air ever gather itself back into one corner without being forced? Could random motion alone recreate the original imbalance? Nothing in the basic rules forbids it. Every individual molecule is free to move any way it likes, and yet, in practice, it never happens. The air spreads. It does not reconcentrate. This simple fact hides something deep. A quiet asymmetry, a preference that does not come from the rules themselves, but from something else entirely. You are standing at the edge of that question now, and once you see it, you cannot unsee it. Now think about something even more ordinary. You push a solid object across the floor, it moves for a moment, then it slows down, then it stops. You don't argue with this outcome. You expect it. In fact, if it didn't stop, that would feel strange. But try reversing the scene in your head. After the object stops, do you expect it to suddenly begin moving again? Do you expect the floor to give energy back and push the object toward you? Of course not. That never happens. And yet nothing magical occurred when the object stopped. The energy it had did not vanish. Energy does not simply disappear. It changed form. As the object slid, tiny interactions took place between its surface and the floor. Atoms bumped into atoms. Motion was transferred. The floor warmed by an amount too small to notice, but real nonetheless. What was once a clear, organized motion in one direction became countless tiny motions in many directions. Instead of one object moving together, you now have trillions of atoms vibrating randomly. This change matters. When motion is organized, it is easy to describe. You can say where it is going. You can say how fast it moves. When motion becomes spread out, that clarity disappears. The direction is no longer obvious. The information is no longer concentrated. This is what people mean when they talk about entropy. It is not about things getting messy in a casual sense. It is about energy spreading out and becoming harder to track. It is about motion losing coordination and becoming shared among many parts. Once that happens, reversal becomes possible in principle, but impossible in practice. You see this everywhere. A bouncing ball rises lower each time until it rests. A swinging object slowly comes to a halt. Machines wear down. Engines heat their surroundings. In each case, energy spreads out and never gathers itself back again. This is not rare. It is constant. But here is the question that should slow you down. If everything is made of tiny particles moving freely, why don't these processes ever reverse? Why don't all those small motions line up again and recreate the original motion? Nothing stops any single particle from moving one way or another. Each one follows the same basic rules. So why does the system as a whole always move in one direction? The answer has nothing to do with force. It has to do with numbers. Imagine shuffling a deck of cards. You mix them thoroughly. When you look at the result, the cards are scattered without pattern. You are not surprised. Now ask yourself how likely it is that the shuffle produces a perfectly ordered deck with every suit neatly grouped. That outcome is not forbidden. It is allowed, but it is overwhelmingly unlikely. There are many, many ways for cards to be mixed. There are very few ways for them to be ordered. The same logic applies to physical systems. When energy is concentrated and organized, there are only a limited number of microscopic arrangements that look that way. When energy is spread out, there are vastly more arrangements that all look the same. So systems move toward states that can be realized in more ways, not because they must, but because they almost always will. This is probability acting at enormous scale. The basic rules of physics do not choose a direction. They allow all possibilities, but probability strongly favors some outcomes over others. States with few possible arrangements fade. States with many possible arrangements dominate. That preference is what gives time its direction. The past corresponds to states with more structure and fewer possibilities. The future corresponds to states with less structure and more possibilities. And this connects directly to you. Your memory depends on stable arrangements of matter. Your brain records information by creating and maintaining order. That requires energy and low entropy resources. The future cannot be remembered because it has not yet taken shape. It has not yet settled into a specific arrangement. The past has. Think about something fragile. You crack an egg into a pan. The shell breaks. The inside spreads out. What was once contained and structured is now open and uneven. You never expect that egg to return to its original form, not because it feels unlikely, but because it feels impossible. And yet, if you look closely, nothing supernatural happened. No rule of nature was broken. The atoms that made up the egg are still there. They simply moved into a far more common arrangement. In principle, those atoms could move back. Every motion could reverse. Every interaction could retrace its steps. The laws allow that possibility. But the odds are so small that the universe will never grant it the time. So the egg stays broken, and the moment passes in one direction only. This is the quiet idea hiding underneath everything. The difference between before and after does not come from a special rule written into nature. It comes from numbers. It comes from the fact that some arrangements are rare and others are overwhelmingly common. Order is fragile because there are fewer ways to achieve it. Disorder dominates because it can happen in countless ways. You are living inside that imbalance. Every breath you take spreads energy outward. Every movement transfers motion to the environment. Every thought requires physical change inside your brain. Each step nudges the universe toward states that are easier to reach. That steady drift is what gives time its sense of flow. But this raises a deeper problem. If everything naturally moves toward less structure, why is there structure at all? Why isn't the universe already smooth, quiet, and uniform? Look around. Matter gathers, stars shine, planets hold together, life builds complexity. Your mind maintains patterns long enough to think about them. This order did not appear by accident. To understand where it comes from, you have to go back to the beginning. As far as we can tell, the universe started in an unusually ordered state, extremely ordered. Not empty or uniform, but arranged in a way that allowed structure to form later. We do not fully understand why this was so. What we do know is what followed. From that starting point, the universe has been slowly releasing its stored order. Stars burn by spending it. Galaxies form as it redistributes. Life exists by tapping into what remains. Nothing is being created from nothing. What you see now is the long use of an initial supply. A useful way to picture this is as tension slowly relaxing. The early universe was tightly constrained, like a wound system full of potential. Everything since has been the gradual easing of that tension, step by step, process by process. You are living inside that release. And once it begins, it does not reverse. Now consider a situation that looks ordinary, but carries a hidden clue. Imagine a container filled with gas, not fully mixed, not neatly separated, but somewhere in between. Some regions are denser, some are thinner. The pattern looks temporary, like it could change at any moment. Now ask two quiet questions. What was this gas like a short time ago? And what will it look like a short time from now? If this uneven pattern appeared by pure chance, then the most reasonable answer is simple. It was probably more uniform before, and it will be more uniform after. The current pattern would just be a brief deviation, a momentary coincidence. But that is not how the world behaves. What we actually observe is the opposite. Systems tend to start out more organized and then drift toward uniformity. Structure appears earlier, not later. Order fades rather than emerges on its own. This difference matters. It tells us that the order we see around us is not the result of random motion briefly lining up. It is not a lucky accident. It is a trace left behind by something that happened long ago. Order is not a fluctuation. It is a record. You can see this by thinking more broadly. If order came from random chance, it would be isolated. You might find it in one place, while everything else remained featureless and chaotic. Patterns would be rare and local. But when we look outward, we do not see that. No matter where we look, we find structure. Matter clumps. Stars burn in predictable ways. Galaxies rotate with familiar shapes. The same kinds of patterns appear again and again, far beyond any single region. This tells us the order is not local. It is shared, it is inherited. The simplest explanation is also the strongest. The universe began in an unusually ordered state, and everything since has been a gradual movement away from that condition. The direction of time follows that path naturally. Once you see this, many everyday facts fall into place. We remember the past because it left records behind. Those records require stable, ordered conditions to form and persist. The future has no records yet because it has not happened. Cause comes before effect. Growth comes before decay. Life unfolds and then ends. These patterns are not imposed by the laws themselves. They emerge from the way order is used up. What you experience as time is not just change. It is change flowing along a gradient set at the very beginning. The beginning of the universe was not just a moment of expansion. It was a moment of unusual structure. Matter and energy were arranged in a way that allowed change to happen later. We do not know why the universe began in such a special state. No current theory explains that choice. It remains an open question. What we do know is what followed. From that starting point, the universe has been slowly spending its order. Stars shine by releasing stored energy. Planets cool by spreading heat. Structures form and decay as energy flows outward. This one-way process defines the direction of time. Some people find this confusing when they look at life. They see crystals growing. They see trees rising from the ground. They see children developing into complex adults. All of this looks like order increasing, not decreasing. But nothing here is happening for free. Whenever a system becomes more organized, it does so by using energy that was already organized elsewhere. The environment always pays the cost. A plant grows by absorbing sunlight. That light arrives in a concentrated directional form. The plant uses it to build tissues, but in doing so, it releases heat into the air. The surroundings become more disordered than before. The total balance always moves in one direction. Your body works the same way. You eat food made of carefully arranged molecules. Your cells break those molecules apart and use the energy to maintain structure and repair damage. Heat is released. Waste is produced. Order inside is supported by disorder outside. Nothing is being reversed. Life does not resist the overall trend. It depends on it. Living systems are not exceptions to physical law. They are pathways through which energy spreads more efficiently. This includes you. Every breath moves energy. Every movement warms the environment. Every thought involves physical change in your brain, and that change produces heat. Moment by moment, you participate in the same process that powers stars and drives galaxies apart. But within that process, something remarkable happens. You experience, you remember, you create meaning. Complexity emerges long enough to notice itself. That complexity is temporary, but it is real, and it is not isolated. The order that allows you to exist did not begin with you. It came through a long chain of events, from food to sunlight, from sunlight to stars, from stars to clouds of gas, from those clouds to the earliest structures in the universe. You are connected to that history physically, not symbolically. The same direction that guides the evolution of the cosmos also guides your life. The flow of time that shapes galaxies is the same flow that shapes you. When physicists talk about the laws of nature, they are talking about rules that never change. These rules describe how matter behaves, how forces act, and how energy moves. They are precise and reliable, and they work the same way everywhere we have tested them. But these laws do not tell a story by themselves. They tell us what is allowed, not what must occur. They describe possible motions, not the actual path the universe takes. To know what really happens, you also need to know how things began. The direction of time comes from that starting point. The rules themselves do not care about past or future. They are balanced. They work just as well forward as backward. What breaks that balance is history. What happened first shapes what can happen next. This is an important distinction. Physics does not say, this must happen. It says, this can happen. The universe chooses one possibility among many, and once that choice is made, everything that follows is shaped by it. Why this particular beginning? Why this particular direction? Why a universe that changes instead of one that stays still? We do not yet know. That uncertainty is not a weakness. It is part of what makes the subject honest. Physics tells us how nature behaves, not why it chose this path instead of another. Some people hear this story and feel uneasy. They hear that everything eventually fades, that structures dissolve, that nothing lasts forever. But there is another way to see it. You exist during a rare interval, a time when the universe is ordered enough to support complexity, but not so ordered that nothing happens. A time when stars burn steadily, planets remain stable, and chemistry can build living systems. You are not outside this process. You are one expression of it. Every structure, including you, will eventually change. That is unavoidable. But change is also what allows moments to exist at all. If nothing ever spread out, nothing would occur. No motion, no growth, no memory, no experience. The direction of time is what gives events their shape. It is what allows causes to lead to effects. It is what lets one moment follow another. Because time moves forward, things can happen. Because entropy increases, stories can unfold. You are here because the universe is not finished yet. And for this brief stretch, this narrow window between what once was and what will be, you get to take part. That is not something to fear. That is something to notice.